Hi guys, good afternoon. So today we'll see about iOS based. Okay, this is what we are going to see. And for this thing, I ask you guys to go to NTP. All of you have checked what is NTP, network time protocol, why it is used. Okay. Network time protocol used to synchronize time between devices. I also said there is you have to check about stardom levels, correct? Did you check? No. NTP stardom levels. Okay, so actually, total 16 stardom levels are there, 0 to 15. Okay, so the lower the stardom level, the more accurate your time is considered. The more accurate your time is considered. Like stardom level 0, that means your atomic clocks, your GPS, your satellites, they are considered as the most accurate clock. Okay, so in the images, you can see this thing. Okay, like this image. Not very much clear. This is not clear. Okay, this one a little bit clear. So you can see like stratum 0 is the most accurate clock, and like your GPS satellites, they will be considered as the most accurate. Then after, whatever the devices or servers will synchronize the time directly from them, they will be considered as stratum level 1. Further onwards, it will be 2, 3, 4, 5 like this. Okay, so it is up to 50. After that, it will be considered not accurate. Okay, this is clear. Now, other than this, other than the stardom levels, I also gave you a task to check something about like saving time. Yes, that is offset. What you're talking about is offset time. Okay. Offset time means, let's say for example, if we talk about a reference clock. Okay. So what is a general reference clock? UTC, right? That is coordinated universal time. Okay. So the coordinated universal time is the primary time standard globally used to regulate the clocks and time. Okay, so it establishes a reference for the current time. Okay, like if we talk about Indian time zone, so it is UTC plus 530. It is UTC plus 530. Hmm? No. UTC. IST is the Indian Standard Time. That UTC 530 is what? IST. That UTC 530 is what? Basically, it is your IST, Indian Standard Time. Okay, so you can check this thing, right? You can go and check your clocks. Like if I click on adjust date and time, see this is the settings menu. Do you see here? It is UTC plus 530. So this UTC plus 530 is basically what? It is our IST. It is the offset. That 530 is what? The offset time. Okay. And if you see this thing, let's say for example, according to this, what is the UTC time? So just remove 530 from there. It will be your UTC 00 time, the reference time. Okay. Now, One is your UTC. Okay, then we have, like I was talking, daylight saving time. Now this is something interesting. Okay, what is daylight saving time? Daylight saving time, also referred to as daylight saving or daylight savings time, daylight time, summer time, is the practice of advancing clocks to make better use of the longer daylight available during the summer so that darkness fall after a later clock time. Might not be easily understandable. So see, let me explain it according to UK. In the UK, okay, the clocks go forward 1 hour at 1 a.m. on the last Sunday in March. That means they will, let's say for example, at 1 a.m. in the last Sunday in March, they will change their time from 1 a.m. to 2 a.m. They will increase 1 hour. Okay. Why? Because from there onwards, summer times start. Summer time starts, summer means days are big now. Days are bigger now. So that means automatically darkness will come on later 1 hour. Is that clear? So this is for summer. Then back 1 hour at 2 a.m. on the last Sunday in October. So in October, winters will start now. So once winters will start, they will go back 1 hour because the darkness will come early. Okay. So this is how, this is what is known as your daylight saving time. Now there are certain locations, where the times like for 6 months it will be night only. For 6 months it will be day only, right? So like polar regions, okay, or North Pole and South Pole regions, they are generally having this kind of signal. Okay. So see, when the clocks are 1 hour ahead, this is called British summer time, and the other will be known as winter time. Is that clear? So this will be known as your BST. And if you talk about your IST, so IST, Indian Standard Time, this is 5:30 hours ahead of Coordinated Universal Time. So UTC 5:30 is what? IST. Okay, this is clear. Now the thing is that why do you need this NTP? Why do you need this NTP?
Synchronous timing devices and to capture then the
So basically, see, all the devices, they are generating logs. All the devices, they will be generating logs. So if your time is not synchronized, if the time is not synchronized, in that case, there will be problems. What kind of problems? Your logs will not have proper time, right? So that means auditing will be difficult, complicated, and relating the logs to each other will also become complicated. Okay. So that's why we want that, okay, the time should be same in the devices. Once the time is same, then after easily we can use, check out the logs and we can investigate the events. Okay. And that means auditing will also become easy for us. Okay. All right. Now see, once we will configure NTP, configuring NTP is not a big deal. Won't have too much of command, but synchronization will take time. Like it's not packet tracer that you will just fast forward and yeah, it will take 30-35 minutes to synchronize. So first of all, the right now, what is the first thing we are going to do is we are going to configure our lab first. And in the lab, we will do the basic configuration, then we'll configure the NTP because it will take around 30-35 minutes of time to NTP server and clients. Okay. So let's go and access the lab. And for this particular, because we will be using CA based VPN, right? So we will create a CA certification authority. This certification authority will do what? This will provide certificates for the clients. That means, see, so far whenever we configured IPsec, right? Always we use the authentication. What was the authentication we were using? Pre-shared. But what if you want to use RSA signature based authentication? So if you want signature based authentication, you will require certificate from the certification authority. and the certification authority will give you the certificate. Certificate will have a expiry time, right? When it was granted or released, and when the certificate will expire. So to maintain that time also we require what? NTP. Okay. So let's go and configure the lab. What about this? Tomorrow we'll see this. Shut down. Close it. Now it's shutting down. Let's go to the event. Stop. Close the lab. And for this reason, we will be using the CSR routers. Okay. CSR routers we will be using.
CSR already takes 4 GB.
4 GB RAM. Correct. They will take up 4 GB RAM. They will not take 1 GB RAM. And here you can, if you want, you can do one task. Cisco has different series of routers, right? So you can check out why each series is used. We have SR, ESR, CSR, why these are used. Okay. Now let's go here, VPN, new lab, iOS, to. Now see, one we will take what? NTP server. So directly I'll use here CSR only. And this will be what are NTP. Hmm? No, if you decrease, then it will work very slow. Yeah, you can decrease, but the working will be very slow. No problem. I'll give you. This is our NTP server. Okay. And then we require one CA server. This will be our server. And since we are using it over iOS, because Cisco iOS is Cisco router, it is using Cisco iOS. So Cisco iOS CA server. Okay. This was a lab in your version 5. PCA exam lab. Then we require ISP. These are cloud based. That's why I said you need to check where CSR is there. You can use simple router also as an ISP, not a problem. This will be our ISP, and for ISP, I'll use the image globe only. So it should look like an ISP. This EVNG 48 GB. 48 GB and 20 CPUs. Server benefit. This one? This one is 16 GB with 8 CPUs. Laptop 32. And then we have site. So 2 routers we will take for site 1 and site 2. On this side, we would use site 1. On this side, site 2. Yeah, 20 GB and one switch we will require, so it will be overall 21 GB. Note switch here.
But they are not possible in our system.
And then you can use remote lab, right? This server, this is required in the night classes. In the evening also I have classes, right? You cannot use it. 8 to 10. FTD was going on. Now NGIPS will start there. Monday. Hmm. Hmm? To run right now, nothing. NGIPS will be like 1 week. ESA 3 sessions. Hmm? Yeah, ESA will be 2 to 4. Okay. So let me just change the names and let's start these devices. Site 1. Site 2. Now let's start all the devices. Then we have iOS list. This is anywhere you can use it. Okay, same. It's like nothing fancy. It's normal site to site VPN only. But here we are just using a CA so that we can use RSA or certificate based authentication instead of pre-share. We will be using certificate based authentication. Okay, because maybe pre-shared keys might get compromised. Okay, so to avoid those kind of scenarios, we can use CA certificate here. Okay, configuration wise also it will not be difficult. See, spatial configuration what we require here, that we will configure CA server and these will be CA clients. Okay, so whenever this guy will be generating, whenever this guy will be initiating the traffic from site 1 to site 2, what will happen? Before sending the traffic, it will download the certificate from CA. It will download the certificate from CA. That means whatever the certificate it will be sending as an authentication, that certificate will be signed by this CA. Okay. So when this guy will receive it, this guy will verify that certificate how? By downloading the private key of the server. And once the private key will be used for decryption, the certificate authority will be validated. How our browser does, right? See here. Let's see if I'm visiting google.com. So how this lock symbol is coming? How we are getting this lock symbol? Because this particular certificate is being verified. So my browser already has the certification authority name that okay, this is the certification authority and I trust it. Now, if anybody will come with a certificate, okay, any websites will come with this certificate, what will happen? Let's say, for example, my system is sending traffic to google.com. So in my browser, the public key is already there. Public key is already there for most common certification authorities. Now what? Whenever I will send the traffic, I will use that public key to encrypt my traffic. And if Google is able to decrypt the traffic, that means now Google is having the correct private key. And then if both sides we have, let's say for example, see what is happening. This is my system. In my browser, I have key certificates, right? I have a public key certificates. And the private keys are available with whom? Google. Okay. The private keys are with the Google. So whenever my system will send the traffic, it will use this public key to encrypt the traffic. So Google has the correct private key. Google will be able to decrypt the traffic. Okay, this is how it is happening. Now, before decrypting the traffic, Google will be able to check this. First of all, my browser trusts this certification authority. So that means I'll get if the connection is getting secure, if correct private key is there. So that means encrypted communication is being established. And when Google will send me any response, okay, so Google will encrypt it with this private key. And then I'm having the correct public key. I'll be able to decrypt it. So this is how it will work. Is that clear? Okay. So this is how we are going to get the information. Remember SSL handshake we studied that the server will send what? Key exchange. Whenever we initiate a tunnel setup, the server will send us what? The key. Okay. Then we will verify it. Once we verify it, after that, first of all, the client will start using encrypted mode of communication. And in the next message, server will also start using the encrypted mode of communication. So this is how we are verifying. In between what? CA will be there to whom we will verify that okay, correct certification authority is there. Is that clear? Yeah. See here. Now if you verify this thing here, now that this particular certificate has been verified by Google Trust Services. So my browser trusts this certification authority. Okay, you can see like what is the common name, okay, what is the organization. Then in the certificate we do have a validity also that from 26th of August 2024 to 18th of November 2024 this certificate is valid. After that this certificate will expire, new certificate has to be generated. Okay, then after CA information also we will have. See, public key is there. Public key information is there. Okay, what is the signature algorithm? So signature algorithm is SHA-256 with RSA encryption. Okay, and these are the certificates if you want to download. Okay. This is clear. Okay, these are different certificates. See here. So same way we will create a CA server of our own. Okay, we will have a CA server of our own. Now see. Hmm? CA in real time we are not using our own CA. In real time our CAs are like this is cert. Yeah, pre-share in some organizations might use it, but some organization who really want their communication to be secure and they cannot have any chance of compromise, so they will go with the certificates only. Okay, so that will depend organization to organization. Now maybe they can have their own CA, or maybe they can use from something like DaisyCert and all. Okay, so first of all, our NTP server is there. So this is, you can call it management subnet, or any subnet you can call it, because this we are using for network time only, synchronizing the network time. Okay, so let's consider this subnet we will use is for 110/24. Okay, this is the subnet we will be using, and from this subnet we will be assigning the IP address. Let's say to the NTP server, I'll assign 21.110. Then this is site 1. So to the site 1, I'll assign 21.1. Then to the site 2, I'll assign 21.1.2. Then to the CA server, I'll assign 21.1.3. This is clear. Okay. So now with this IP addresses, NTP communication will happen. And this is site 1, this is site 2, and this is the iOS CA server. So we right now we are using iOS, it can be any other CA also. So now what is going to happen, that these are connected via what? ISP. And ISP means these are different site 1 is different autonomous system, site 2 is different autonomous system. So whenever you want communication between different AS, what do you need? BGP. BGP will be required. So in this part, we will be running what? BGP. Okay. So let's use a circuit. So in this part, we will be using BGP. Okay, in this part, BGP will be running. And in BGP, we will require autonomous systems. So here I'm considering we have AS number 1, since this is site 1. This is AS number 1. So here we have AS number 1. This site number 2. Here on this side we will have AS number 3. And ISP is connected to everyone. So let's say on ISP we will use something like 1, 2, 3. Okay. Now this side also we need networks. So let me design some networks here. One network here we will require 1.1.1.0/24. This is one network that we are going to have this site. And then the site 12 we can use RC. Some ISPs are also not going to assign completely different class itself or completely different network itself. They will use like this because ISPs will use subnetting more than anyone else. Okay, so you can consider 12 also. That is also totally fine. It is no big deal. Okay, because eventually how we use the IP address, that is going to be the same. And here we can use, I'm just changing the third part because I'm using /20. Okay, this is done. Now from these subnets we need to assign the IP addresses. So here, let me change the color. This side we will use the IP 111. This side we will use 2.2. Can use 10. And then here we can say 2.10. This will be 3.10. This will be 3.3. Okay. Then here one loopback we will require for site-to-site communication because we will be configuring policy-based VPN. Okay. And one more loopback we will use. Why? Because whenever these sites want to communicate with the CA server for enrolling for the certificate, that time we want that, okay, communication should happen via loopback. Because again, physical interfaces have a possibility of going down, right? So we want that the communication should happen via loopback, because loopback interface will never go down, right? So that is the reason. So let's configure one loopback. So let's say here I'll configure at 0, which is going to have an IP address 1.1. Okay, this is our one loopback, and this time /32 we will use. Okay, single IP only we are using, not entire subnet. And again, if you want to use also, you can use, because the way we will advertise in the BGP same. Okay. Let's bring it up here. Let's bring this back here. And here it will be 3. And here it will be. This is for communication with the CA server only. That whenever I will enroll that, okay, I want a certificate from the CA server, so that communication I will have using this IP. I don't want to use public IP for that communication. Correct. Okay, so I don't want to use public IP for that communication for getting the certificates. Okay. So this will be 2. This is clear. And every time, whatever the loopback we are using for the site-to-site communication, 10.1.1 and 10.1.2. So that one, 1.1.1.1. Yeah, correct. Yes. This will be our interesting traffic, which will pass through the tunnel. So actually, when we see tunnel will be established between site 1 and site 2 only. Okay. This is clear. This is our lab setup. Now let's go for the basic configuration. It's okay, I can do it. Basic configuration. First of all, let's go for entity server. Neighbor. Distribution terminal. Hostname. Interface. Now, interface, if you see here, we don't have Z0 by 0 or Z0 by 2. We have gig 1, gig 2. So Z1, G2, like this we will have. Let's say G1. Okay. Then let's say IP address 110.255.255.255. 0. That's it. No shutdown. This is done. Then, not on NTP. This is our NTP server. On NTP, we don't require. We just require between site 1, site 2. Okay. And you see it. So, neighbor. These routers are more capable for virtualized environment. If you want to try the thing out, yes, you can try. Yes, they are supported. Using CSR then. In the exam, let's say you go for CCA exam and there you come across CSR router, then you will look at different icon and you get scared. No plan, but in the company, if they say, okay, this is CSR, CSR is a virtualized, actually, it is not a physical device. Okay, this is not a physical device. Yeah. Cloud service router. Okay, host name is done, then interface. One IP address 113.255.255.0. And interface G2 IP address 11.1.3.3 255.255.0. Shutdown. Loopback 0. IP address 172.16.1.3 255.255.255. This is /32. Then after we have site 1. Okay. So site 1 we have to configure. This configuration will almost remain same. This is site 1. G1 IP address is 21.1.1. G2 IP is 1.1. Loopback 0 IP is 1.1. This loopback 1. Channel interface. No. Policy based VPN. Okay. Site 1 done. Site 2. G1 will be 21.1.2. G2 will be 2.2. This loopback will be 1.2. And this will be 10.2.2. Now ISP is remaining. What happened? Now let's configure ISP also. So Z1 will be 11 1 1 11 1 3 10. G2 will be 1.10. G3 will be 1 2 10. This is ISP done. So these are the basic configurations done. BGP you will use, right? So this is the basic configuration done. Now next thing we require is what? BGP. So first let me do this configuration in the devices. Let's access the NTP server, access the CA. Okay, then access the ISP. Site 1, site 2. So once we do the basic configuration, we will test the connectivity between AS and site 1 and NTP, site 2 and NTP, and we will test public to public connectivity from your
Site 1 to site 2.
But will we have public connectivity? No,
No.
because we have not configured routes yet. BGP we will configure, but yet right now we have not configured. No. How this guy will come to know that how do I reach 11111? Will not know, right? Yeah. No. Yeah, ISP we have to configure. ISP we will have to configure.
How can we
We cannot control, but on ISP side we'll already be running, right? BGP. This is used by ISP only, different autonomous system. So whenever you will take a connection from ISP, when you will take a fixed connection from ISP, whenever you will take an IP address from ISP, whenever you will tell them, so they will tell you, they will configure it for you. That okay, this is your IP address and this will be your gateway. Okay, same thing. The same thing is going to happen here also. Because who is responsible for providing internet communication? ISP only. Okay, so this case BGP we can run. If you want to run AGRP now, no, that is not going to work. That's why we are using BGP here this time. Okay. Now see, let's go and do the basic configurations. NTP server, initial configuration dialog, no. Yes. No. It is asking, would you like to enter the initial configuration dialog? Same like iOS routers. We say no. So it is confirming that do you want to terminate the automatic install of configuration? Yes, I don't want. I will manually do the configuration. We don't want to automatically install, right? So now let's go and then it will start auto install. Okay. So one by one. Okay, still they're coming up. Meanwhile, they're coming up. Let's go and write down BGP configuration also. I hope you guys already know how to configure BGP. Right? Configure BGP. Okay, so first of all, let's say I'll configure it on the CA server. On the CA server, I'll say router BGP and AS number is 3. Then neighbor. Then directly you want to define a network. Okay, what is the IP address? Okay. 111310. Directly AS number.
Wildcard mask.
Wildcard mask. No, no. Reverse it. Always you will define network first. Okay, so what is the network running here? 11.1.3.0. Mask for this network. Is your loopback. So 172.16.1.3. Mask is this. Then you will say that my neighbor, which is my 11.1.3.10, belongs to the remote AS and okay. And one comment I will give here that I want to log if any neighborship changes there. So I'll say BGP log neighbor changes. Okay. This is one comment that I'm going to use here. So this is done for the CS server. Now, next is you will configure, let's say, on ISP. So on ISP, you will say router BGP 123, and the same command you will use. Okay. Log neighbor changes. If neighborship changes, they're like going up or down, so that should be logged. Okay. And what are the networks on ISP? So on ISP, we have network 11.1.1.0 and mask is 255.255.255.0. Another network we have 11.1.2.0. Mask is then we have 11.1.3.0. On this command I copy. Now here neighbors will be 1.1 remote AS 1. So this will be 2.2 remote AS will be 3.3 remote AS will be 3. Okay. Then on ISP, then on site 1. Okay, so site 1 almost similar kind of configuration is going to be there. So router BGP on site 1 we have 1, network we have 1.0, this IP address will be 1.2, 20.0. No, this we will not advertise. Okay, the NTP part will not advertise. Look at we advertise 1.1. Yeah, only one, because this traffic is going to pass through the tunnel. Because whatever I will share in BGP, that information will go to ISP also, CA server also. I don't want my interesting traffic to go there. Okay. Okay. That's site 2. So site 2, BGP is 2. Here we have 2.10. This is 2. This will be 2.10. This is clear, right? So site 1 is done, site 2 is done, CA server is also done. Okay, all good. So now let's go and copy paste the configurations here. This will take some time. These will take time. RTCP, okay, you have test costs. Awesome. Okay, allow it to, right now allow these devices to come up. Let's go for further configuration. See, now once we configure BGP, all the routes will be exchanged and we will have communication from this loop back to the other loop back also. Okay, that means L0 to L0 communication we are going to have, public to public communication also we will have. Now it's time that we synchronize our time using the NTP. So we will configure what? We will configure NTP. So this is going to become our NTP server, and this AS1, your AS3, and your AS2, that is your site 1, site 2, and CA server, they will become your clients. Okay. So next thing we have to configure here is what? With authentication, we will configure. Without authentication, one line commits are there. NTP master and NTP server. Okay. So say on the NTP server, say master, then you'll give what? Stratum level. You will say NTP master 1. Then you will say NTP key or trusted key. Stratum level. Right now I showed you, right? 0 is for satellite and all those things. Okay. See here. First of all, we will say NTP master, then through which interface you want to synchronize, that interface you will give here. Okay. So interface is what? NTP source, and what is my source interface will be? G1. Okay. This is going to be my source interface. Then I will say authentication key. Okay, and in the authentication key we will have a hyphen. Then we will give a key ID. Okay, so key ID, anything you can give 1, 2, 3, 4. Okay. So you can give any random number here, and then after we will give the algorithm, which algorithm you will use. So let's say MD5 algorithm you want to use, and then what is the key you want to use. This is my key. Okay. Once this is done, then you will say you want to do what? You want to authenticate entity. So entity ID, identification of the key, like key number you can say, key number 1, key number 2, like this you can say. This is just a identification. Okay, and then you will say that you can use any. Then you will say in sorry. You can say that. No, it's not like that also. It's an identification, like in the OSPF router, OSPF1 we use, that is process ID. So like that, it's just an identification. Okay. And then you will say that NTP, and you will trust the key. So your trusted key will be what? The key ID number 12. So that means this is the key that you are trusting. Is that clear? Okay. This is your server configuration. Okay. Then on the NTP clients, who will be your NTP client? Your CA server, site 1, and site 2. These are going to be clients. Now on the client, see, you will, instead of NTP master, we will say NTP server. Okay. We will say NTP server, and the server IP is what? 21.1.10, right? 21.1.10. And now here you can say that which key again you want to give. Identify number is 12. Identification, that is what I'm telling, right? Now here also we will generate that key, same process. Here also you give the same three comments. Copy, paste. So now whatever the number you will be generating here, that same number here. Is that clear? No, you can use different numbers also. Because eventually for authentication, this is used. This key number you can use locally. Is that clear?
When client, that the identification number is not.
Ah, not unique.
But it will be local also.
Ah, it will be local because eventually authentication will happen through what? This one. It's like, what you give a ACL name or so. So on all of these clients, the same comments will be there. Okay.
Also entity stores available as address.
No, not required. Where? This one. No, here you will use the interface there. Who is the source? Either IP address or the interface name. Okay. So let's go here. Yeah, these devices are now off. NTP server, copy. Still taking time. Configuration dialog, no. Do you want to terminate auto install? Yes. I forgot to type yes earlier. Here we'll say no. By default also it's yes only, so not a problem. This is starting. So iOS CA server has started. Then we have server. It will start again. That is terminate auto install. Okay, CA server is up. So let's paste the CA server configuration first. Copy. They are a bit slow. Copy. Site 1 is fine. Site 2 is fine. It's almost fine. This is not responding. Okay, now it's getting pasted. IP ambiguous command. Okay, it's not IN. We have to type in for INT interface. Okay. Other than this, interface G2 has been taken. Loopback has been taken. So this configuration I will copy again. Paste again. Okay. Only one interface configuration was having a problem. So now interface configuration is fine. NTP server, it will take up some time to come up. Meanwhile, ISP configuration. Copy. Again, here also interface, one interface. 20 CPUs are for the Eve only. Here we could have assigned more number of like 2 CPUs. By default, they are taking one only. Right now, only 5 CPUs are being used out of 20. Even G, complete even G. ESXi 24. Okay, G1 should be up now. Okay, so this is fine. Everywhere I have to go and say interface first. Then we don't have any interface configuration. ISP configuration is pasted. Now site 1 configuration. Copy. And then we can go and paste site 2 configurations. Already 322. They only NTP synchronization will happen. After NTP synchronization, we don't have much part. Just start. CA we have to configure, after that IP set. That's it. So still coming up. This is taking a long time. Let me do one thing. I'll just write these configurations, whatever the configurations we have in these devices, and then I'll assign more CPUs. So it will be a bit faster. CA server is not updated. Let me stop this lab. edit, not 8, 3 CPUs to each. Now this time it should be faster. See, this time they will be faster. So we'll do one thing. I'll just cancel today's technical session and we'll complete this. Interview prep. Now Ola coming up. So this time they are fast, not like last time. So now, yes, ISP configuration is already there. We configure it. So some of the configuration is saved. Some of the configuration was not saved. Okay. CA is working fine. Now all the devices are working fine. So NTK server. Copy. paste. And this is NTP configuration, CA server configuration. So now they are not sticking. Earlier they were getting stuck. Copy ISP. Again ING3. This is interface IT. Then after site 1 configuration, in the system, that site 2 already there. Still let me paste. Okay, now everything looks fine. Then what we'll do is we are going to configure BGP. So on the CA server first, copy. This is the CA server. Configure BGP here. Then on the ISP, copy. And once we paste this BGP configuration, our neighborship should come up. Copy. Neighborship should come up, as well as we should have the routes on the sites also. See, coming up. The neighborships are coming up. So when I check on site 1, I should have a route for, see how many routes I should have. On the site 1, when I will check, so I need a route for this network, this loopback, and another loopback. So total 4 routes at least I need, right? So let's check on the site 1 to IP route. Okay, so BGP neighborship is up. Now it will take some time for the routes to get flooded. Okay. So the routes will get installed in the devices. Till now, it will come up. Okay, in some time. Neighborships are up. You can see that ISP is neighbor with all three. Okay, and I think RDP about to go.
Again.
No, comments will not be on. This is only RDP. At the last moment, always this thing happens. RDP goes off, internet goes off. No, today we'll complete this. For this, we just need CA configuration as well as. After this, last VPN, tomorrow L2TP. No extra classes.
You are going to start.
Yes, I will start. Show IP. Okay, at the site 1, we have to check. Right. So now I can see that I have route for 11.2, 11.3. Okay, 172.16, 1.2 as well as 1.3. So that means now my loopback to loopback communication should happen, right? So what I'll do is I'll test communication from 1.1 to 1.2. Okay. So what I'll say here, I'll say do fail 172.16.1.2, the source 172.16.1.2. We have the communication. This communication is fine. Yeah, loop back 0 to loop back 0. This communication is okay. Now we need to configure NTP, because NTP will take long time, very long time. Okay, you can check what is the time right now, 3:35. Okay. This is NTP server. Now, meanwhile, we can talk about the CA configurations. Now, clients will be home, CA server. Okay, then site 1 and site 2. So this is the client configuration. Copy it on the CA server, copy it on the site 1, copy it on the site 2, so that the time will get synchronized. Always remember, with the help of NTP, your time will get synchronized, your time zone or offset time will not get synchronized. Okay. NTP is also only capable of synchronizing time, not the offset time or time zone. Okay. So now if I go on the NTP server and if I check do show status, so you can verify here that the stratum level we configured here is what? 1. So stratum level is 1. And what is the reference clock? Local. That means itself is the NTP server. And what is the clock status right now? Unsynchronized. And if I go and check on the site 1, so NTP status. Okay. So right now it is showing stratum level 16, and it is not considering any reference clock. But once the NTP configuration will come in picture, reference clock will be 21.110 and stratum level will become 2, because it is synchronizing from 1. Okay, and same thing, same output we will see here. Okay, so NTP status. So right now same thing is here. Okay, then we have CA. So status here also right now not synchronized. And since on ISP we have not enabled NTP, so you will see this is clear. Now it will take some time for this configuration to come up. Okay, again if I check, do show NTP status, right now unsynchronized. Now see how we will do the configurations. First of all, this CA server, I use CA server, I will configure it as a CA. Okay. Once we configure it as a CA, then after these site 1 and site 2, they will enroll to the CA server. They will enroll to the CA server. So what we will do, see, on the CA we will generate a public and private key, and on the site 1 and site 2 also we will create public and private key. Okay. Then after, what the site 1 and site 2 will do, they will send their private keys to the CA. CA will sign the private keys with its public key. Sorry, with its private key. They will send public keys and CA will sign those certificates with the private key. Okay. And then we will be sending the traffic between site 1 to site 2. Is that clear? Okay. So everywhere we have to generate the keys. Okay, so how we will generate the key? Using the RSA, crypto key generate RSA. Okay, and then here, this one we will configure it as a server, and your site 1 and site 2, we will say that if you want to enroll, so you will enroll using this loopback IP, which is 172.16.1.3. Okay, and for that reason, we have to provide a URL, and for URL, we will be using the HTTP service. That means we have to enable the HTTP also on the your CA server. Is that clear? Here, when these guys will enroll, so we will have to provide a URL. And for that reason, we will need to enable HTTP here on the CA. Like HTTP : 172.16.1.3. No page. This will be backend communication. Here we don't have Windows client. This will be backend communication. Okay. So internally they will access the CA page, okay, and they will download the certificate. This is only the case. Okay. Now NTP will take time. So meanwhile, see, let me show you the book. There's a book that I'll be sharing with you. See here. How to set up and deploy a Cisco iOS certificate server. Okay. So see here. So first command will be we want to generate the certificates. Crypto key generate RSA. Okay. Then exporting and all this thing we don't want to do right now. We'll use this command and then configuring the certificate CA server. So this thing we want to configure, right? So we will use the command what? We will say crypto PKI server and we will give a name to it. Okay. That is the certificate server label will give like my CA or whatever the name you want to give. Okay. So, and for this region, do you see we have to configure what? HTTP server also. So we will be configuring HTTP server as well. Okay. Everywhere AI is there. Huh? Ask AI assistant. Okay. So this thing we will give, and this will enable the CA service, but we do have to configure certain parameters also. Okay. So some of the parameters what we have to configure is first point we will configure in the clients. Okay. In the client side, we will use this command crypto PK trust point. So this will declare the trust point that your subordinates server should use and enters the CA trust point configuration. So basically here we will this command we will use on the client and the command crypto PK server. This command we will use on the server. Okay. Then after we have anything else, yeah, this one. So we will give these parameters like issuer name, like whenever you visit, if you have seen here, we have things in the certificate. What are the things? Like what is the common name, which is CM, what is the organization, okay? So these things we do have to configure there. Okay, so how we will configure it? We will configure it via like this. CN, whatever the name, common name, okay, and then after organization name, whatever you want to give, okay. So we will use cisco.com like that, okay. These things we are going to configure. Then we will say grant auto, okay. So that means automatically grant the re-enrollment request. That means anybody is coming for enrollment, so automatically enroll and grant the certificate, okay. That we will say, and then at the end we will use a no shutdown command. Okay, so this no shutdown command will do what? It will enable our CA server, certificate server. Okay, and once our certificate server is enabled, it will ask you for passwords. Okay, it will ask you for password because see, we for certificate server, public key and private key will be generated. So to secure the private key, it will ask us for password. So we'll give a password also. Okay, that will be our part. So see what the comments will look like. Configure iOS. Okay. So on the CA server, you will say first thing we require a domain name. So you configure a domain name. You will say IP domain name. Let's say Cisco dot. Then a relevant DNS server also you can define. So IP DNS server. Do we have a DNS server right now? We don't have a DNS server. So we can give here any random IP. Let's say any IP. Let's say for an example, any one. No, 1110 is any random IP you can give. That is not an issue. It is just required, so we have to give it. Okay. It also you can give. But right now we are talking about our local DNS. So you can give any DNS server in your organization. Okay. This is you can give, and then after we will generate the keys. Again, ID keys creating issue. The crypto key generate RSA. And right now we will give it a name also, that why we are creating. So label also we can give. So let's say name to this particular key, label to these keys. I want to give what my CA, and I want to say modulus. Let's say 1024. Done. Once this is done, after that we will enable HTTP server. HTTP server. Then after, now once HTTP server is configured, right? After that, see here. Once HTTP server is configured, then we will configure what? The PKI server information. Okay, so crypto PKI server, and then I will give a name to my CA, which is my CA. Okay, so let's go here and configure. I'll say crypto PKI server, and I'll name it that the name is what? My CA. Okay, once this name is given, now in this CA we will need a database also. Okay, there will be database of all the certificates. Okay, so I'll say database. Okay, and what is the status of my database? It will hold names only, or it will have a minimum information, or my database information is complete. So I'll say my database information is complete. Okay, then once this is done, then after, remember I said we have to configure certain parameters also, like we have to use the command is your name, then common name I have to give, and I can give organization. Okay, so these things I can mention. So I'll say issuer hyphen name. Okay, and I can say common name is what? Now what is the common name? So this is my CA, so let me call it my CA only. Okay, or whatever you want to call it. C and common name. So I'm saying that this is my CA. Okay, you can call it my CA, whatever the common name you want to give here. And then organization, let's say again Cisco is my organization, so I'm using cisco.com here. Then certificate request, so it will grant the certificates automatically. And then we will give what? The command shutdown. Country also, if you want, you can say country India also, you can say. See, these are optional parameters if you see. But few things, whatever the information you want to include, these are optional. So see, it is up to you. If you want to give or if you don't want to give, it's completely up to you. You can use Cisco also, not a problem. Okay, this is not an issue. You can use here anything. Okay, this is clear. Okay. Once you give the no shutdown command, here it will ask you about password. Okay, it will ask you about password. So let's say I will give password as sys0123 to protect my private keys. Again, I will give 0 1 2 3, because it will ask us for password and it will ask us for confirming the password. Once these commands are done, our IOC server is set up. You will see that your certificate server is enabled. And if you want to debug, if you want verification, so how will you verify this information? Crypto. So this is how you verify, and there you should see the status as enabled only. So let me check NTP. Okay, authoritative clock has been set. I think time has been synchronized. Let's see. NTP status. So at the server, it is showing what? Synchronized. Okay. But here we don't get that log, right? Once you will get this log, right? Authoritative clock, the system clock has been set. If this log you get, that means your NTP is synchronized. Okay. Now let me check. NTP status. This is still it is unsynchronized because here we don't get that log yet. Okay, once we will get that log, then after we will see. Status. So here, do you see stratum level? It has taken 2. Reference clock it has taken 21 but still the clock is what? Unsynchronous, because we still didn't get that log. So here also same thing, and on the C still, yeah, here also the same thing. So now in some time, like it's already 35, almost 3:35 we started NTP, and it's almost how much time? 17 minutes already. So it will take some more time. Okay. Now see here. It's okay. Okay. So here server configuration has been done. The CA server configuration is done. Now on the client side, what kind of configuration you will require? So keys we have to generate there. And then this time, like I said, instead of PK server, we will deliver what? PK trust point. Okay. So how the configuration will be on the client side? See here. So let's say I'm configuring on site 1. Okay, so this much configuration will remain as it is. Copy, paste, and instead of my C, I will say that okay, I'm generating this time for site 1. Okay. Then I'll say to PKI first point. Okay, and I will give a name. Here we don't require, only on the server we will require HTTP, because these guys are clients, they will enroll there. Okay. Huh? No, we don't need to enable. That is in the ASA. Okay, HTTP server enable, that is in the ASA. Here IP HTTP server is enough to enable. Okay. Once we give this, then we will give what? Enrollment URL. We'll say enrollment. Then you will say URL. Enrollment spelling, I think correct. Correct, right? So we will say http:// and what is the loopback IP? Check here. Because we want loopback for enrolling the certificates. 1.3. So I'll say 172.16.1.3 with the port number 80. This is done. Then we need to use RSA key pair here. So I'll say RSA key pair. And what is the RSA key pair I have created here? Site 1. So same RSA key pair I'll use here. Site 1. Okay. Then Here we have to mention the interface also, that if you are taking the interfaces, this is the site one. So which interface it will use? Okay, so it will use IP address. So either I can give the IP address 172.16.1.1, or I can say you can take the IP address from the interface loopback 0, right? So I can say you can take the IP address from loopback 0, and I will mention the source interface here. So my source interface will also be no loopback 0 only, because I cannot use my public interface for this. Okay, for certificate purpose, I will use my loopback interface only. Is that clear?
Then DNS local maybe
Hmm?
on every.
DNS server, this is a IP. See, one DNS server will be there, right? That same IP you will use everywhere. Okay, this is clear. Once you have given this, then we will say that subject name. Okay, and again here we will use the same parameters. That what is the common name? So this is site one. So I'll say common name is site one. Organization. Let's say again here I'm using Cisco. Okay, and if you see here, one more thing should be there. Status is right here. See here, this is the configuration we are doing right now. Okay, that we give the crypto PK trust point, we give the name, enrollment URL, then we give the subject name also. Okay, these all things have been given. Subject name has been given. Now see, whenever you one more parameter is there that I want to show you. See here, when you look at the certificate, there is something called as CRL. Okay, there is something called as CRL. Now see what is CRL is. Certificate revocation list. IDP. RDP wants to go out. Needs a break. CRL. CRL. What's wrong with this? See, what is CRL? Behaving like this. Certificate revocation list. So this is a list of digital certificates that has been revoked by the issuing certificate authority before their scheduled time. So sometimes what will happen that it will tell your CA that okay, what certificates have been revoked and what certificates have not been revoked. Sometimes I have given a certificate, but before their expiry time itself, I want to revoke the certificates. So where your site one will check it. Okay, what is the method they are going to use? So the method we are going to use is what? Basically this CRL method we are going to use. Okay, so this will work. This is very slow. Okay, 1 minute. I'll turn off the Wi-Fi. See here. So here we will say revocation. Okay. So where it will check the revocation in the CRL. Then after once this is done, after that we will say that we want to authenticate this. So I'll say to API authenticate, and what I want to authenticate, site one. This is the I want to authenticate, and where I whom I want to enroll, I say crypto API enroll, and I want to enroll whom, site one. Once I give this command, enroll site one, you will see that my site one will download a certificate. It will enroll itself on the CA and it will download the certificate. Okay, those things we will see. Okay. So same thing, same kind of configuration we can do on the site two also. And how you will verify this? Verification, how you will do? You will say web2. No, this is VPN right now. Anything in the interview prep you have to say? Yeah. Today I cancelled it because VPN is going to take a long time. So tomorrow? Tomorrow is. So you will say here to web2 API certificates. So you will see what are the certificates downloaded. Okay. And same configuration for site 2. Okay. Similar configuration we will do for site 2. In the site 2, DNS is not going to change. This we will change to site 2. This we will change to site 2. And this URL will remain as it is. Site 2 loopbacks are also same. Only this thing we have to change. This we can change to site 2. This is it. This is only the change. We have to do it on the site 2. Then once these two things are done, now last thing we will remain with configuring IPsec. Okay. So last thing we will do here is what? Configure IPsec. IPsec configuration we already know. The IPsec IKE v1. Okay. According to this, if we will configure, see, let's say I'll configure on site 1. Second policy 10. Then hashing algorithm, if you want to say, see, generally if you don't define anything, if you just want to change the authentication method also, you can change the authentication method itself. If you want to define, like if I will not define anything, it will take base algorithm and then SHA-1 and group default it will take. Okay. So if you want to define, you can say, let's say for example, hashing you want SHA-256. Okay. Then authentication. This time we will not say authentication pre-share. This time we will not say authentication is pre-share. We will say that authentication is what? RSA signature. Okay. This will be a algorithm. Okay. Then after you can define encryption is AES group as 14 lifetime. If you want to define, by default it will take. Okay. Then after this, what do we do? Key we define, but this time the key is there where? Certificate. The key is already we have configured in the certificate, right? So what we will do here directly, crypto IPsec transform set and then ESP AES ESP SHA HTML. Okay, this is done. Then after this, access list 100. Now here numbered or name, whatever you want to use, it's up to you. Okay, so let's say access list 100 IP. Now if you go according to your CCA exam, how it was in the CCA exam, you have to use named access list. Okay, so you will say IP access list extended, and let's call it VPN. Then you will say permit IP from 10.110.000.255 to 10.2.2.0.000.255. Okay. Then after, once you have configured this access list, then you will say what? Crypto map, CMAP 10. Then done. Then set transform set T set. Here, who will be my peer? Tunnel is between site 1 and site 2 only. Tunnel is between site 1 and site 2 only, right? Then match address in the crypto map. Yeah, match address. Then you will say VPN. Okay. Then you will apply it on the interface. Interface, and what is the interface? G2. Then you will say crypto map. Okay, and same sort of configuration you will do. Copy. To source will become destination, destination will become source. Then peer will be changing, that is 1.1. Okay, and interface is G2 only, so not a problem. Okay. Not much of a configuration, only 300 lines. Right? Okay, let's verify what the, which routers. These are all CLI based only. Okay, no GUI. Okay, see, now we are getting this log, right? That the system clock has been set. So now if you check, show NTP, you see clock is synchronized. Same thing here also. NTP status, clock is synchronized, as well as on the side 2 also. To entity status, this clock is also synchronized. Now clock synchronization is done. What? In NTP server it is 1, that's why here it is 2 everywhere. Okay. In the NTP server you can see here NTP status. Okay. All right. This is done. Now let's go and configure the CA. So first of all, I'll not give this command, that no shutdown command. Until no shutdown, I'll copy all the comments. Okay. Copy. Configuration terminal. Paste. Okay, one. Okay, after DNS space will be there, not, and also in the domain. No, domain space will come, right? Space will be here. Copy. And this. Okay, DNS server. DNS server. It's fine, right? What's wrong? No, no, no. DNS server. Okay, let it be. Hmm? Okay, server. To enable DNS server. Okay, IP DNS primary. No, no. Okay, let it be. No, it's not about that. It's not taking an IP address. DNS. Okay, let it be right now. So see, so far what I have been configured, our domain name is configured, and you can see once I said grant auto and I configured the crypto PKI server and MyCA database level is complete. Issuer name MyCA and organization Cisco grant auto. So it says what? It gave me log that a key named MyCA has been generated or imported by the crypto engine. Right? Now all I need to do is what? I have to go back to this my server. Okay. And here I have to say no shutdown because keys are already generated, right? If I say no shutdown, do you see it says some server setting cannot be changed after the CA certificate has been generated. Please enter a passphrase to protect the private key. So I want to protect the private key and I'll give the password sys0123. Same password we enter sys0123 and you will see that it will say that trust point my CA created successfully. Okay. And do you see certificate server has been enabled. So our certificate server is ready. How we can verify that the certificate server is ready or not? So I can say do show to API server. If I say this status should be enabled. And right now our status is what? Enabled. Okay. So status is enabled, state is enabled. Issuer name is MyCA, organization is Cisco. And CA certificate, these are the fingerprints. Okay. What is the database level? Complete. Fingerprint kind of you can say hash value only. Okay, it will not show the actual CA certificate here. Hmm? That is, like I said, these certificates we cannot see. It will be the backend communication only. Okay. All right. This is done. Okay. Now, another thing here we can see is show crypto API. Crypto API. We can see here sessions. Right now it is not showing a session. So right now it is showing that okay, one session started, one session ended. There is no active session right now. Okay. As well as if I want to check the certificates, so see here, crypto certificates. Okay. Right now I have these certificates. CA certificate is status is available, and certificate usage is what for signature. Okay, who is the issuer? MyCA, organization Cisco, subject is this, and this is the date and time. That starting date is 19th of September 2024, ending date is after 3 years. This is clear? Okay. Now, CA side configuration is done. Now let's go and configure site 1 and site 2 also. Let's go to global configuration mode. And this DNS command is not working right now, so let me comment it. And here domain and name will have a space. Okay. Okay, it is not DNS server. We have DNS only we have resolver. Yes. This will be what? Name server. This is what we have to configure. Copy. The CA. Okay. Why we require this? Because whenever you will be signing the certificates, whenever you will be communicating, so that time you are communicating with the domain names, right? So these domains will be looked out. Like I have configured this domain name. Okay. So they will check the domain. In the real scenarios, right now we are just using random IP because we don't require. Okay. So same thing here. This will be name server. And here also this will be what? Name server. So now and here this. Let's copy the site one configuration. Oh, not this. Now on the site one also you will see that I will first of all I will go until here only. Okay. Copy. This is site one. One comment subnet name. There is subject name. We have to say name. Okay. This will be subject name. And this will also be. Okay. Now this is configured. After that, we will authenticate it. So I will give the authentication command. Do you see? The certificate has the following attributes: MD5 and SHA-1. Do you accept this certificate? Also, yes, I accept this certificate. Do you see Trust Point's CA certificate has been accepted? Then after, I want to enroll this certificate now. Okay, I want to enroll this site one now to the CA server. So see here. Now start certificate enrollment. Create a challenge password. You will need to verbally provide this password to the CA admin in order to revoke your certificate. So that means if your admin wants to revoke the certificate, you have to tell them the password. So right now we don't want to allow because we have granted automatic certification. So here I will not set any password here. Just keep it blank. Okay. Then it is asking include the router serial number in the subject name. So no, I don't really want to include my router serial number. I'll say no. Request the certificate from the CA. So yes, I want to request the certificate from the CA. And do you see? We get certificate request fingerprint is this, certificate request fingerprint for SHA-1 it is this one. And ID certificate has been installed under site one, MyCA Cisco, right? Let me just expand it a little bit. Okay. So just wait for it. It will take a certificate. Okay, starting date, end date, those things we will see here. Okay. Now how we can verify here? We can say show API certificates. Okay, so you can see who is issuing the certificate? MyCA, which is a CA server, is issuing the certificate. And what is this name? Site1.cisco.com. What is the IP address? So this is how the identities will be verified this time. Okay. Then 172.16.1.1. Then host name is this. Common name is site1. And you see my certificate is valid for 1 year. My certificate is valid for 1 year. So this is why NTP is required that from this time to this time the certificate is valid. So the time is mentioned within seconds here. Okay. Now This is the information about your CA certificate, licensing the root CA and all. Okay, that information it is. So this is iOS self-signed certificate. And who is the issuer? Again, we can see IC. Is that clear? And we know that for CA certificate, earlier also we saw that it is 3 years validity. And for the client certificate, it is 1 year. Okay. Now, the same configuration, we will do it on the site 2 also. Okay. Check it. Copy. Go to the site 2. Paste it. Done. So you can see trust point site 2 created successfully. A key name site 2 server has been generated and imported by the crypto engine. Okay. Then we will authenticate and then we will enroll. Copy. Paste. So yes, I will accept this certificate and then I will enroll it. Okay. Copy. Paste. Enter. No password to be set here. And yes, no, I don't want to include the router's serial number. And I want to request from the CA. Okay. So now the certificate has been requested from the CA. You can see my CA has given me the certificate. Okay. Okay. Now everything is done. All we need now, last thing is configuring IPsec. Once we will configure IPsec, that time these guys will download one certificate from the CA. Okay. So now what I'll do is let me go here and let me capture the packet sets Z2. Okay. Let's say on the site to site, I'll capture Z2. Okay, so right now no packets are traveling. Okay, right now if I try to ping from my site 1 to the loopback 10.2.2.2, will I be able to ping? No. So let me try. If I say do ping 10.2.2.2 with the source as yeah, we don't have route also and tunnel is also not there. Okay, so let's go and configure our IPsec. So site 1, copy. This is site 1 only. Paste. Something is wrong. Set here. Okay. Wait. No. This is only crypto map problem, right? Crypto map 10. Here. Crypto map, C map, and then who will say IPsec is a camp? Then after set here, set transfer, set all those comments. Now it will work. IPsec. Copy. Okay. And I think it's already applied on the interface. Interface it is applied, but it says crypto map does not exist. So now we have to apply it again. Copy. Paste. So we should get ISA campus on. And same thing here. IPsec. And here also copy. Site 2. Paste. Done. ISA camp is on. So as of now, we should not see anything here. Okay. These are just BGP keep alive messages. Now what I'll do is I'll ping.
And
Okay, and let me do one
thing
site one only, I think, and I'll see here. See, I'll debug the PKI messages so that we can see. Debug crypto PKI messages. Okay, here also I'll start. Crypto PKI messages. Now let me try to ping 10.2.2.2 using the source as 10.1.1.1. Let's see what do we get. Some issues there. Isaac camp is on both sides. Isaac camp is on. 11.1.1.1. Then we have 11.1.2.2. Okay. What about ping 11.1? This is fine. Check something we have missed. No, it's not established. NTP CA server is done. Almost everything is there. Let's okay, this one command, let me check. Reverse route static. Not done. Reset. And second. Crypto. Reverse route. To and reset. Jump. To that was only the thing. Okay. Do you see envelope content? Messages. We will see. Okay. That log message, what I want to show you is verified the signed data. Okay. So the certificate was signed from the, see here, verification has been done for the trust point site one. Okay. So if you have this communication, that means basically here what is happening, see, what is the authentication mechanism we were using? RSA signature. Okay. So using the RSA signatures, using the certificates, we have done this authentication. Okay. So undebug all here also. Here one command you have to add in, that is not here. This is only our method. route, and here also the same thing, reverse route, because the route was not getting created, right? For the 1022 route was not getting it. Now let's capture the packet C here. ESP is there, but do you see there is a communication between 1.3 and 1.2, right? This was for getting what? This was for getting the certificate. This was for getting the certificate. Client made a request to the CA server to get the certificate. And then see here, the CA server replied, okay, with application with the PKI message. Okay. So if you look at this, you will not really see the certificate here. Okay. Media type is the PKI message. HTTP, if you will see. So see here, this is coming from, what else you can see? It's so the certificate data we will not be able to see, okay, because that is encrypted using RSA. Okay. But these requests, we can see that a request was made from the client. Okay. And if you see in the first message and second message, we see the authentication mechanism and all, right? If I open the first message, ISACAM, Security Association, then we have proposal payload, transform payload. In the transform payload, authentication method is what? RSA signatures. Okay. And you can see authentication method is RSA signature. We used AES 128, SHA 256, DH group 14 we used, and this is the default lifetime 86,400. Is that clear? So remaining everything is as it is, but only this authentication method we wanted to use the certificates. This was the overall idea behind using your CA. Is that clear? So this is your iOS CA based VPN. Okay. Very simple. Yeah, this notepad actually.
How do you remember it with what the command
Don't remember the comments, remember the concept.
concept, but
If you see in this VPN, what is the change we have? What is the change we have? One, BGP configuration is there. Second scenario, CA is configured. So how much CA configuration is there? See here. Barely 3-4 lines of comments. And then we can take help, right? See, it's very simple. Like if I go and Google and if I say that iOS server configuration example, that's for example. So from Cisco itself, see here, managing certificate server. I can open this document, I can open this document, and this is from security VPN itself. Okay, this is the same document I have shown you right now. Okay. Generate and export the RSA key pair. Then we have verified the pair, enable the HTTP server, enable and configure. See, PKI server, Cisco 1, database URL, database level. So here it is set minimum. We could set complete, right? Then issuer name is there. This is the names we can give here. Then after lifetime, if you want to give, you can give, otherwise it's fine. Then after these CDP URLs, if you want to give again, you can give, otherwise not required. Directly you can say no shutdown. Then configure and enroll the second iOS router R2 to the certificate server. Now see here, generate the keys, domain name, okay. Then this is the command. Trust point command we used. We gave the URL. We just didn't give these two. Retry count. And revocation check, here it is saying none. We said what? We used the CRL. After that, we authenticated, we enrolled. Comments are already available. You don't have to remember all the comments. Okay, this is clear. Then we can use this show crypto CA certificates, and this will give us information. So I can go here on the site one. say show crypto CA certificates. It's not there what? CA command is not there. Okay, CA certificates is not there. We can use PK certificates. So here we can see the certificates. Exactly. So this is my certificate I have received. Okay. This is clear. All right. So this is iOS CA server done. Now last VPN tomorrow, that is L2T. Layer 2 tunneling protocol. Do some research about L2T because it is widely used. L2TP is widely used. And let me save this. COS iOS CA server is site to site. Even we cannot remember all the commands. Not possible. How many commands you will remember? But you must know the source. Source, if you know, see exactly 300 lines. Okay. So this notepad I'll share. Apology is there. Hmm? See, where you have to take care about the copy pasting is until basic configuration, NTP configuration, you don't need to worry about anything. Okay, only in the CA configuration. In the CA configuration, after the no shut, it will ask you about password. Okay, and when you're configuring clients, so up till revocation check, when you will authenticate and enroll, that time it will ask you password. When you enroll, it will ask you password, and when you will authenticate, it will ask you to accept the certificate. So these two things you have to take care. Okay. All right. And if you want, you can make these things. You can type in yes here, and that will be done. But better you face it, so you come to know where it will prompt and where it will not prompt. So up till revocation URL, you can check. Okay. So let me do one thing. I'll make a little gap in this. That will help you. Now you can check. Then IPsec, we don't need to worry about anything. IPsec is all fine. Okay, save this configuration, copy. Might be, might not be, because like might be this command config show crypto CA. So all these commands are same only, right? See here, instead of crypto PK, here you will have CA. In the normal router, you will have crypto CA, not crypto PKI. For server, it is PKI. For clients, it is CA. So better to use CSR only. Which one? Where? I'm not sure which one you're using. Let's check it right now only. First, let me stop the recording.